All right, let's get right into it. Today, we're basically going to be detectives. We're on a mission to solve a really neat little algebraic mystery. We've got our suspect, this variable c, and its true identity is hidden. Our job? To crack the case and unmask it.
Okay, so this is it. This is our case file. At first glance, this thing looks kind of messy, right? X squared minus c all over x minus b. But here's the key piece of intel. We're told that this whole thing is secretly the same as the much simpler expression x plus b. That right there is our first big lead.
So what's our mission? Simple. We've got 4 possible values for c, but only one of them is the real deal. The others? They're just decoys. We need to use the clues hidden in the problem to figure out which one is the true value.
So that's the big question, right? What is the secret identity of Crick? It's time to gather up all our evidence and start putting the pieces of this puzzle together.
Okay, so just like any good detective, the first thing we've got to do is look at the clues. And in our case, the clues are the conditions and the definitions that are spelled out right in the problem. Let's break them down. Okay, clue number 1, and this is a big one. B and C are positive integers. Now, what does that actually mean? It means we're dealing with clean, whole numbers. 1, 2, 3, and so on. No fractions, no decimals, no negative numbers allowed. This is huge because it really narrows down the field of possibilities.
And here's our second clue. That little phrase, equivalent to. Now, this is super important. It doesn't just mean the two expressions are similar, it means they are the exact same thing. That messy fraction is just the simple x plus b wearing a clever disguise. For pretty much any number you plug in for x, you'll get the same result on both sides.
All right, let's pull everything together on our detective board. What do we know for sure? Fact 1, b and c are positive whole numbers. Fact 2, our two expressions are identical. And fact 3, x can't be b, which, makes total sense because you can never divide by 0. With our facts laid out, it's time to do some real detective work.
Okay, now for the fun part. We're going to get our hands dirty with a little algebra. This is where we connect all the evidence and basically force C to spill its secrets.
So here's the plan. First, we write it out. The big fraction equals x plus b. Now, to get rid of that pesky fraction, let's multiply both sides by x minus b. Boom! That leaves us with x squared minus c on the left and x plus b times x minus b on the right. And hey, wait a minute. That pattern on the right should look really familiar. That's the classic difference of squares, which expands out to x squared minus b squared. So now we have x squared minus c equals x squared minus b squared. And check this out. We can just cancel the x squared terms on both sides, and we're left with this beautiful, simple connection, c equals b squared.
And that, right there, that is the breakthrough moment. This is the aha moment of the entire investigation, where everything just clicks into place.
Suddenly, the mystery is gone. We know exactly how c and b are related. It's simple. C is b squared. This one little equation is the key to the whole puzzle.
And think about it. This connects right back to that very first clue we found. Remember? We know b has to be a positive integer, like 1, 2, or 3. Well, if c is just b squared, then c has to be the square of a positive integer too. This means c can't just be any old number, it's got to be something special.
And that something special is called a perfect square. You know what these are, right? It's just a whole number times itself. So, 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16, and so on. Our culprit c has to be on that list.
Okay, we've done the hard work. We have our key piece of evidence. We know exactly what kind of number we're looking for. It's time to bring in the suspects, our answer choices for a final lineup.
All right, let's run through the lineup. Suspect number 1 is 4. Is it a perfect square? You bet. It's 2 squared, so it fits the description perfectly. But let's check the others, just to be thorough. How about 6? Nope, not a perfect square. 8? Not a chance. 10? Definitely not. The evidence here is just crystal clear.
So yeah, there's only one suspect that even matches the profile. It's 4.
And just like that, case closed. We started with this complicated-looking problem, we followed the clues, we did a little algebraic digging, and we uncovered the secret identity of C. It had to be a perfect square, and 4 was the only one in the lineup.
So what was the big secret here?
It was spotting that classic pattern, the difference of squares. Now that you've seen how to crack this case, what other problems out there do you think you can solve with this little secret? Thanks for joining the investigation. We'll see you on the next one.